In this section, we discuss types of databases. This brief presentation was organized by Dr. Alemi and narrated by Farhat Fazeliar. Data used to be kept in a table, with variables as columns and records as rows in the table. Over the years, this arrangement proved to be insufficient. It was especially problematic when some data were repeated needlessly. Then data were kept in hierarchical databases, where subset of data were kept in separate tables. One table contained one set of variables and pointers to other tables, which included subset of data. This concept was generalized in relational databases, where the subset of the data was non-hierarchical. Relational data are the most common databases these days. Recently, there have been also more emphasis on object-oriented or federated databases. Flat databases have minimum structure, essentially being one large table. First row is a list of variables and subsequent rows are the data. The flat file styles of databases are ideal for small amounts of data that needs to be human readable or edited by hand. This table shows a flat database. We have shown student ID, name, midterm grade, final grade, address, and zip code. There are 3 rows of the data in the database, each row being a separate record. There are 2 Mike Smiths in this class. There are big problems with flat databases. Suppose you have 1 or 2 students in the class, multiple addresses. You can add a new field called second address, which would be a blank for most students except those with 2 addresses. For example, if 90% have 1 address, only 10% have 2 addresses. The 90% value of the addresses are empty. There is a lot of wasted space. The problem gets worse when a few entries have more than 1 data items for the variable. If there are multiple phone numbers, we would need to create multiple fields. If the person has 5 phones, we would need to create 5 additional fields that could be blank for all the individuals with only 1 phone number. Soon we will have a huge table which is mostly blank. To find an actual second phone number, we would need to search through thousands of people who don't have second numbers. That slows our computers and makes every search and every analysis problematic. In a hierarchical database, data are organized in parent-child relationships. Each parent can have many children, but each child has only one parent. You can imagine the hierarchical database as a tree. It is similar to the structure of a filing system. It was largely adopted during the 1970s to 1980s. It was used in healthcare and banking systems. It works well when the concept being analyzed is in fact hierarchical in the real world. For example, students in the health informatics program are a subset of the health administration program students. The program students are a subset of the college students, and the college students are a subset of the university. Other example, biological organisms and plants are organized in a tree structure, so the database designers can borrow the real-world relationships to structure the database. Here is another example of a hierarchical database. A person can be an employee, patient, or a contractor. Employee can be administrative or clinical. Patients can be in the ICU or in the clinic, and so on. Hierarchical databases are so rigid in their design that adding a new field or record requires that the entire database be redefined. Furthermore, each child in the tree may have only one parent and relationships between children are not permitted. The relational database is the most commonly used database today. It was invented by Dr. E. F. Code of IBM in 1970. Oracle delivered the first relational database. The relational database is essentially a collection of tables. Formally, the link among these tables are called relations, and this is where relational database gets its name. The first relationships in a relational database do not need to be hierarchical. Here is an example. This database has two tables. One describes the students and the other gives their grades. The ID is used to link the two tables. In this fashion, we can see that Ali Godri has a final grade of A. We can look up his ID from the student table and then use his ID to find his grade. This grade table can grow without needing to duplicate the information in the student table. There are many reasons why relational databases are preferred to flat files. First, in relational databases, data can be examined from many different perspectives. The relationship tells us the perspective we wish to take. Second, there is no need to enter missing information for variables that are not logically possible. This saves a great deal of storage space and later analysis time. Third, it is easy to modify relational databases as adding new concepts involves adding new tables, not altering old ones. It is not easy for the end user to run queries on a relational database because the needed data must be reconstituted from complex combination of many tables. In object-oriented databases, data are organized in a form of objects that represent real-world entities. Each object has its properties that can be regular values or other objects. Each object consists of two elements, data and instructions for what to do with the data. Relationship between entities is via message, not joint fields. Here we see a purchase order object that has a message to where the product should be shipped and has been embedded instructions. Object-oriented databases are efficient. They use the actual real-life entities as objects, and thus it is easier to understand and remember the organization of the data. Reusable objects can be created in different projects. The ability to mix and match reusable objects provides incredible capability. A distributed database is a database in which storage devices are not all attached to the common CPU. It may be stored in multiple computers located in the same physical location, or may be dispersed over a network of interconnected computers. A good example of federated database is a blockchain database in which separate machines maintain copies of transactions. Systems can be modified, added, and removed from the distributed database without affecting nodes currently in the system. Even when a portion of a system that is local site is down, the overall system remains available. With replicated data, the failure of one site still shows access to the replicated copy of the data from another site. This remaining site continues to function. Users at a given site are able to access data stored in other sites and at the same time retain control over the data at their own site. A federated database integrates multiple autonomous sources of data into a single federated access. This allows user to access all databases through one step. To the user, it appears as if they were interacting with a single database. A good example is the web. The web is a federated database, and when you access the web, you feel like it is all in one place. In reality, each web page can be in a different database. Security of these databases are difficult to maintain. Many agreements must be made ahead of time. Patterns in the data can be used to rediscover de-identified data. A federated database is complex and extra work must be also done to maintain multiple disparate components of the system. In addition, at time of analysis or research extra database design work must be done to account for disconnected nature of the database. In federated systems, additional software is required. Operating system should be supported distributed environments. And finally, concurrency control is a major issue. Systems must keep each other informed of changes. Relational databases are prevalent, efficient, and what this course is about.